Hello, and welcome back to Shiksha Costa. Today we're going to start a new unit on connecting the graphs and equations of exponential functions. In this unit, in general, you're going to learn how to simplify and evaluate numerical expressions, so expressions that have just numbers in it that involve exponents. Then you're going to make connections between the numeric, the graphs, and the algebraic representations of an exponential function. As part of this, here are some of the specific things you'll do. You'll determine through an investigation what is the value of a power that has a rational number as its exponent, for example, a fraction. You will evaluate with and without technology a numerical expression that has an integer or a rational exponent and has a rational base. You will graph, again, with or without technology, an exponential relation that looks like y equals b to the power of x. As long as b is a positive number, so it's greater than 0, but it's not 1, because 1, we'll see, will just end up being a flat line. You'll define this relation as a function, b to the power of x, and you'll explain why it actually is a function. You'll also determine through an investigation what are the key properties of exponential functions like domain range, intercepts, increasing and decreasing intervals, and something new called an asymptote. You'll also determine, again through an investigation, what are the exponent rules when we multiply or divide numbers that involve exponents. What's the exponent rule for numbers that involve powers of powers? And you'll use these different rules that we've determined to take an exponential expression that has numbers and make it simpler. We'll simplify it. And finally, you will distinguish, you will basically be able to say what is the difference between an exponential function and a linear and a quadratic function in all sorts of different ways. To start off, when playing Monopoly, Declan gets a card that says collect $50 from each player. There are 4 other players, so to find out how much money he's owed, he just goes 50 plus 50 plus 50 plus 50, and he finds out that in total that would be 200. But what operation would have been faster than adding the same number 4 times? Pause the video here and think about that. Hopefully you got multiplication, right? When you're adding the same number again and again and again repeatedly, we call that operation multiplication. You can multiply instead to make it a little bit faster. This number just tells you how many times you're adding the same number. Now, Declan doesn't want to play Monopoly anymore. He wants to make his own game. In it, players will battle to control areas with armies of little soldiers that are represented by tiny, tiny miniature figurines. Now, he wants players to be able to make groups of soldiers as follows. 3 soldiers together, like this, will form what's called a fire team. Three fire teams together will form a squad of soldiers. Three squads will form what's called a platoon. Three platoons will form a company. And finally, 3 companies together will form a battalion. How many soldiers will he need to be in one battalion? Well, let's see. This, going all the way back to where we started here, these 3 soldiers here form a fire team. And then we have 3 groups of them. And I can draw that out here, right? There's the 1 group, there's the 2nd group, and there's the 3rd group. So we could just do 3 times 3 to see how many soldiers are in a fire team. We can also, let me circle that fire team right there. So if we say, okay, that's a fire team, well, here's 1, 2, and 3 fire teams. So we can say we have 3 groups of this. So we can multiply by that by 3 as well to form a platoon. So this group right here would be a platoon, and that's 3 groups of fire teams. Now, if we say 3 platoons together, this one, and this one, that's 3, they all form a company. Well, then this big guy here is a company. And to find out how many soldiers are in a company, I can take the results from a platoon and I can multiply that by 3. And finally, to find out how many companies are in a battalion, well, I've got a battalion here. Sorry, that's a company, excuse me. Let me just erase that. That's a second company here. And that's a third company here. So basically, I can take the number of soldiers in one company, and I can multiply that by 3 to find out how many soldiers are in a battalion. Altogether, I'm taking the number 3 and I'm multiplying it, same number again and again and again, a total of 5 times. And the shortest way to describe this is using a power. 3 to the power of 5 is how we say this, and that means 3 times 3 times 3 times 3 times 3, which is 243 soldiers. So when we repeatedly add the same number, we call that multiplication. And when we repeatedly multiply the same number, we call that exponentiation. A power is a way to express that we are doing this operation called exponentiation. And this is what a power looks like. It's comprised of 2 parts: the base, which is the number that we are multiplying again and again and again, and the exponent, which is how many times we're multiplying that number. So that's what this says here. This is the base being multiplied repeatedly, and the number of times we are doing this is represented up here with this little number at the top, which we call the exponent. To get some practice in this, ask yourself, what is the expanded form of 9 to the power of 6? You can pause the video here and then resume it when you've figured it out. Well, 9 to the power of 6 simply means we're taking this number here, 9, and we're multiplying it by itself a total of 6 times. And that's it. Now you're ready to start this unit. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.